We solve a typical second-order constant coefficient differential equation by the method of undetermined coefficients. We type in the following differential equation: d 2y by dt squared plus 3 dy by dt plus 2y is equal to, let's say, 5 divided by 3 times e to the minus 4t, comma, uc. uc meaning undetermined coefficients. We tap here for an answer. Black light goes on, it's calculating. Once the light goes off, the calculation is done. The calculation is done. We go down. There's our answer here at the bottom. Go to the top. We explain. Starting with the homogeneous equation. By putting the right-hand side equal to naught, and we write down the quadratic, lambda squared plus 3 lambda plus 2 equal to 0. Lambda squared is like your second derivative. Lambda is like your first derivative. The coefficient of lambda squared is 1. The coefficient of the second derivative is 1. The coefficient of lambda is 3. The coefficient of the first derivative is 3. The coefficient of y is 2. So we solve this quadratic and we find that the roots are minus 1 and minus 2. So the general solution of the homogeneous equation is then yh equals constant c1 e to the minus t plus constant c2 e to the minus 2t. Going now for the non-homogeneous equation, where the right-hand side is 5 over 3 times e to the minus 4t. Now we compare this particular problem of ours with this general form here. A, second derivative of y with respect to t, plus b, first derivative of y with respect to t, plus c times y equals a e to the alpha t. Take note that a is the coefficient of the second derivative. In our case here, it is 1. B is the coefficient of the first derivative. In our case here is 3. C is the coefficient of y. In our case here, it is 2. Capital A is the coefficient of this exponential. In our case, it is 5 over 3. Alpha is the coefficient in the index. In our case, it is minus 4. We will refer to A, B, C, capital A, alpha below. Now the trial solution of this general form is given as y. There are 3 possibilities. The first possibility, y is equal to c e to the alpha t. If alpha is not a root of the quadratic, ar squared plus br plus c is equal to naught. It is equal to c times t e to the alpha t. If alpha is a root of the quadratic, ar squared plus br plus c is equal to naught. And it is equal to ct squared e to the alpha t. If alpha is a double root of the quadratic, ar squared plus br plus c is equal to naught. Now there are basically 2 methods that we can use to find this coefficient c, capital C. The first one is we substitute the trial solution into the left side of the non-homogeneous equation, and eventually we equate coefficient of like terms to solve for the coefficient capital C. Alternatively, the coefficient capital C can be calculated as follows. If alpha is not a root of the quadratic ar squared plus br plus c is equal to naught, then c is given by this formula here. If alpha is a root of the quadratic ar squared plus br plus c is equal to naught, then c is equal to a over 2a alpha plus b. If alpha is the double root of the quadratic AR squared plus BR plus C is equal to naught, then capital C is given as capital A over 2A. Now, the alpha in our case here is minus 4, which is not equal to either of the roots, minus 1 and minus 2. So that means the first form for the solution applies. So that means we will have to substitute for capital A here, which is 5 over 3. We substitute in here. Small a, coefficient of your second derivative, which is 1. Alpha squared. Alpha here in our case is minus 4. So do minus 4 squared. Plus b, the coefficient of the first derivative is 3. Substitute in here times alpha, which is minus 4. So it's 3 times minus 4. And then plus c, which is the coefficient of y, which is 2. Substitute in there, make a calculation, and we find that c is equal to 5 over 18. So our particular solution yp is 5 over 18 e to the minus 4t. The general solution is homogeneous plus particular. So it is c1 e to the minus t plus c2 e to the minus 2t plus 5 over 18 e to the minus 4t.